Welcome to my channel. This is the next session in control system. Today, let us see the mathematical representation for the mechanical system. And the mathematical representation for the mechanical system, there are three elements, namely the mass, spring, and the damper. The mass is given by the notation M, and the spring is given by the notation K, and the damper is given by the notation B. And the mechanical system is usually classified into the translation system and the rotational system. Okay, and the translation system, it consists of three elements, namely the mass, spring, and the damper. And in the rotational system, it consists of three elements, inertia element, torsional spring, and the damper element. The torsional spring and the damper element are one and the same, similar to that of the translation system. In the translation system, the notations are, the element notations are mass and the spring. Spring, I represent this as K, and the damper is B. In the rotational system, the inertia element as J, the spring element as K, and the damper as B. Only the name differs as torsional spring and the damper element. As by the notation, you realize that this translational element and rotational element one and the same, only the name differs. And the elements in the translation system is given as mass, spring, and damper. And in the rotational system, it is inertial element, torsional spring, and the damper element. And coming to the translation motion, let us see one by one element. In the case of translation motion, it consists of three ideal elements. Ideal element is said to be as it is fixed at the one end. Okay, this is the mass element. In mass element, it is fixed at one end and it is tended by the force F of t, and x of t is the displacement, v of t is the velocity, which is accepted by the mass element, right? Usually, the force exerted and the mass is given by m into a. This is nothing but mass into acceleration. Okay, the acceleration can be written as dv by dt, and dv by dt is equivalent to, I am replacing dv by dt as d square x by dt square. So the force on the mass element with one end is fixed is given by md square x by dt square. Okay, and similarly here the next element is nothing but the spring element. The spring element is given by the notation K, as said earlier. The spring element, the two ends are the free ends. One end is given by the displacement x1 of t, and another end is given by the displacement x2 of t. And the force exerted on the spring element is given by F of it is equal to k into x1 minus x2, the difference between the two displacements accepted and the spring element. And x1 minus x2 is given by k into the x. F is equal to k into x. This is for the spring element. And next for the damper element. In the damper element, similarly, similar to that of the spring element, the damper element, the two ends are free ends, and it is excited by the displacement x1 of t at one end, and displacement x2 of t at the other end. The force exerted and be written as F into V1 minus V2, the difference between two velocities, and it can be also written as F into X, which is equal to V. Okay, and these three are the for the case of ideal element representation of the translation motion system. And if suppose, let us, we are considering an example, when an example is given us The ideal elements are fixed at 1 and this is fixed at n1. It consists of a mass m and having a displacement x and exerted by the force F. This is the spring element x and the damper element F. You can also give the notation as K and B also. Whatever be the notation, depending upon the notation, you try to write the force equation. Generally, by applying Newton's law of motion for the free body diagram, this is the free body diagram. For the free body diagram, we are going to have a force equation. From the force equation, we are further going to simplify. Uh, by applying Newton's law for the free body diagram, which consists of elements, mass, spring, and the damper element. These three elements, by seeing these three elements, the system is said to be as the translation system. And according to the Newton's law of motion, yeah, I am going to write the total force acting on the mass. Total force acting on the mass is given by force exerted by the spring element and the force exerted by the damper element, right? As discussed earlier, the force exerted by the mass is given by F is equal to m into d square x by dt square. And the force exerted by the spring element is equal to, I am writing the notation as spring element as K and the damper element as B. So the force exerted by the damper element, I am considering this as F form and considering this as Fk, which is equal to K into X. Only X is the displacement, right? And for the damper element, Fb, which is equal to K, sorry, B into dx by dt. Okay, the total force exerted by this is given as, consider the equation as B and this is K. The total force excited by the is the sum of all F is equal to F firm plus FB plus Fk. And I am substituting in this equation. Consider this the equation as 1. F is equal to md square x by dt square plus b dx by dt plus kx. So, in the free body diagram, if there is only one mass and for the particular mass, the spring element and the dashboard is a dashboard element, sorry, then you can also say this is the dashboard element or this is the damper element. So, dashboard element and the spring element are together connected to the mass and it is excited by the force and a displacement x. Okay, instead of this, if the free body diagram is in such, if it is the K and this is the damper element and which is connected towards the mass element m1 and in between the mass element there is a spring element and which it is connected to the another mass element and it is exerted by the force F of t and the upper end is fixed towards. Okay, if it is this and it is displaced by the means of the displacement x1 and it is displaced by the means of displacement x2, if it is 1, you have supposed to get a 2 equation depending upon the elements acting upon the masses. For the mass 1, the spring k1 acts upon it and spring K acts upon it and the damper element B also acts upon it for the mass 1. And the mass 2, the force F of T and the spring element K1 will act upon it. So, viewers, just don't memorize the free body diagram and the writing the equation, realize the free body diagram and see how many elements are acting upon the mass element and depending upon this write the force equation. Okay, if it by after this lecture let us see some MCQs on the translation mechanical system for your gate preparation, TRB, TNEB, etc. else. If you like this video, like, share, and subscribe. Thank you.